Hello students, Professor Benavides here. Let's talk about chapter 8. Let's drill down on passing a list to a function. So to repeat that, or to phrase it in a question, can you pass a list to a function? And the answer is yes. You'll often find it useful to pass a list to a function, whether it's a list of names, numbers, or more complex objects such as dictionaries. When you pass a list to a function, the function gets direct access to the contents of the list. Let's use functions to make working with lists more efficient. So we'll develop that idea about efficiency in this section here. Let's look at an example. Say we have a list of users and want to print a greeting to each. The following example sends a list of names to a function called greetUsers, which greets each person in the list individually. Let's take a look at this. I'm going to do a control plus sign so you can see the code a little bit bigger. So we define greetUsers on line 3. So it expects a list of names, which it assigns to the parameter names. The function loops through the list it receives and prints a greeting to each user. We define a list of users and then pass the list usernames to greet users in our function call. So this is the two parts that I just mentioned. Line 9 is the function call. Line 3 is the function definition. You can expand and collapse these. These are kind of like useful. I like these little down pyramids on here. So what happens here is, the first thing you're going to have to do is you're going to have to go ahead and create your function definition. And we're using a loop, and it's going to loop through the list. It's as easy as that. And then on line 9, we create our list. Has 3 names in it. And then we call greetUsers and pass the list. So when we pass the list, user names pops into names. Very important that we look at this and we see how a different list name was used here. I guess you could say variable name, but that's important because later on when you're doing debugging, you want to go ahead and follow the contents. And it's helpful to know that names is the list as it's being modified within this function, okay? So to run it, Control B, and there it is. Hello, Hannah, hello, Ty, hello, Margot, right? Hopefully nobody here is going to say Margot. But yeah, it's Margot, right? I guess that's a French name, right? Maybe. So there we go. That's our first little example here. Let's talk about modifying a list. Can you modify a list in a function? And of course, the answer is yes. When you pass a list to a function, the function can modify the list. Any changes made to the list inside the function's body are permanent, allowing you to work efficiently, even when you're dealing with large amounts of data. So what we want to do here, first of all, let's look at an example without a function first. And then what we're going to do is we're going to go ahead and make it more efficient, okay? So first of all, let's consider a company that creates 3D printed models of designs that users submit, designs that need to be printed or stored in a list. And after being printed, they're moved to a separate list. The following code does this without functions. Let's take a quick look at this. So line 2, I've got a list. Line 3, I've got an empty list. Okay, so far so good. Then I have a while loop. And it will go ahead and loop through the unprinted designs. And then down here at the bottom, we've got the displays all printed models. So we say print the following models have been completed. So it says for completed models, for completed model, incompleted models. Okay, because we're going singular plural and it's simply printing it. So let me go ahead and run it and we'll see. So let's see now, where we're getting, so it says the following models have been printed. That's the bottom part down here. And then this little while group right up here, while printed designs, in this particular case, just to go over what's going on here, unprinted underscore designs dot pop, that's getting the last one, remember? It's getting the last one. So, and it's getting it and it's putting it in the list that's empty. So it gets the last one. See if you can pronounce this. Dodecahedron. Okay. So it gets that one in there and then robo pendant and then phone case. Okay. So it's going to pop each one of those into the current design. And then the magic happens here is current design. That's just a holding place, right? That's just a holding place. That particular element is then appended to completed models. Okay, so that's the blast from the past. This is a blast from what, chapter 3. And what we're doing here is we're printing a formatted string that says printing model and then the current design. So that's where it says printing model, dodecatron, right? And it's followed by a robo pendant and phone case. And it comes in that order because remember pop takes, it's kind of follows that stack idea. It gets the last one off the stack and it puts it in this variable called current design. And then we print it and the current design is then appended to the empty list. So the empty list ends up having that same order. Here we see it here as it's being printed with this other loop, right? So line 7 says while on printed designs. So that as long as this evaluates to true, it will continue to loop. And this other loop here is for completed model incompleted models. That will continue to loop as long as you have something in completed models. So, you know, we've seen this idea before. It's simply a way of popping things out of one and putting it in the other. So basically, if you pop them all out of unprinted designs, you would expect that unprinted designs would be empty, right? Okay, that's what I would assume too. So, but that's not the main idea here. The main idea here is we want to go ahead and reorganize this code so that it is more structured, so that it is structured in a way that can be more easily maintained and better understood. Maintain means that since we're going to make things very modular, we're going to be able to go in there and make a change better than if they were not placed into functions, right? So we want to reorganize this code by writing 2 functions, each of which does one specific job. And that's a really important idea. If you find yourself doing more than one thing in a function, you really should break it down into another function so that you can think modularly, and of course, so that you could then, you may have, there may be a necessity later on to call that particular idea. So most of the code we won't change. We're just going to be making it more structured. So the first function will handle the printing of the designs, and the second will summarize the prints that have been made. So let's go ahead and take a look at that. And I'm going to do a control minus sign so that we can see the idea a little bit better here. And I added a few little things at the bottom here. And let me just go ahead and go over it. Control B, you end up with the same output as before, except I added something at the bottom there. So we have, when we look at this, we can see that it's structured a little bit more, not a lot more than before. We've got two, right? We've got two methods. And then on line from 17 to, I guess, to 24 is the body. I guess you could call it the body of the program. So what we do here is we go ahead on line 17, we have one list and then another list. Then I go ahead and call print modules. And I pass it these two lists. So inside of print modules, we see that on line 1, we have two parameter variables that receive two lists. I then use a loop to go ahead and pop out from the onprinted design and place it into current design and then print, just like we did before, and then append. We did that before, right? The benefit is that we can go ahead and do this many, many, many times now, right? We can call this as many times as we want. Now we have another function called show completed modules that has one parameter variable called completed models, excuse me, and it goes and has a printed string followed by a loop that prints the completed model. Okay. The only thing that I added on here was on line 23 and 24 is just to simply prove that idea that the unprinted designs, that list is then empty. Why? Because we popped out the last one and we place it into the completed models on here. So if you want to look at the output on here, it's the same as before, except that now I'm proving that there isn't anything in the unprinted designs, right? Let's verify that. Look at the code. Yeah, unprinted designs. Okay. So basically what you had was that you had, the unprinted designs and they ended up being moved over to completed models. So then we ended up calling the model that the first function did pop them over one at a time, right? And as it was popping it, they were being removed from the unprinted designs. And then we go ahead and call the function that prints the completed models. And then just to prove that the list is empty, I simply go ahead and print out the list. And that's where you get the square brackets with nothing in it, right? Okay, just a little proof, just to prove. So when we look at the body of the program, let's look at it one more time, the body of the program. We can see that in a way, it's kind of like easier to understand what the program is doing. And the other thing here is that these function names, print models and show completed models, well, they're descriptive function names. They're very well created so that really you don't, in a way, you don't even need comments to understand what they do. The function on line 1, what does it do? It prints the models. What does the function on line 11 do? Line 11, what does it do? It shows the completed models that have already been printed. Okay, so that's one of the major benefits of having descriptive function names. This program is easier to extend and maintain than the version without functions. So we've got these methods in here, functions, and we can call them as many times as we want. They're very modular, and they do only one thing. Remember, we want to go ahead and make sure that all of our functions do one specific job. And this is a great example of the idea that every function should have one specific job. Remember that you can always call a function from another function, which can be helpful when splitting a complex task into a series of steps. So no, I don't know about you, but I have found myself, confessions told, right? You create a program and you don't have, you're just doing one line after the other, and then you realize, this is going to get bigger, and then you start partitioning it into, functions, and then you start organizing things, and so of course you could have started from the very beginning and done a grand design with, maybe some flow charts or some, other graphical tools that help you to flesh out the solution to your problem, your algorithm. So that brings us now to the next topic here, which is preventing a function from modifying a list. So sometimes you want to prevent a function from modifying the list. So what we're going to do is we're going to use the slice notation. Remember that? When did we cover that? I think that was when we talked about lists, maybe chapter 4. So the slice notation is the colon, and it makes a copy of the list to send to a function. So let's go ahead and take a look at that example right here. And basically the magic happens on line 21. That's where the magic happens. So the slice notation makes a copy of the list to send to a function. And let's just follow through on the logic here. We've got the same two functions, right? We've got the unprinted designs list on line 17, the completed models on line 18, and then we have our print we have two calls. We have on line 21 the print models call, and we pass it unprinted designs of square brackets colon. That sends a copy. So when it comes in here and we're popping things off of it and putting it into another, it's being done to a copy, and then the original list is not modified. So your author didn't do this, but I wanted to prove that the original list was not modified, kind of like the opposite of what I did before. I proved that the list was empty because we were popping them out. I said, well, why not go ahead and prove that the list is not empty? So let me go ahead and run this again. And then we see at the very bottom, we have the list being printed and the original list, and it is not empty, like it was before. All right, so that's pretty much the end of the chapter's, idea here. Let's go ahead and look at the try this yourself. And let's look at them inside of Visual, Studio Code, just to go ahead and do something a little bit different. And this first one is called 8.9 messages. Make a list containing a series of short text messages. Pass the list to a function called show messages, which prints each message. Very, very simple idea here. So we've got our method definition right here on line 4. I'm expanding and collapsing it for you. I do that sometimes just to make sure that everything is in, that the body is all enclosed and I don't have anything sticking out somewhere where it shouldn't be. So on line 10, I create my list. And then on line 11, I pass the list to the function. Very easy idea. So when I pass messages, it's going to go ahead and then come over here to line 4. And then I'm going to loop through it. And I'm going to say for message in messages, print message. So let me go ahead and run that. And it prints hello there, how are you? And then the smiley face, because that's what's inside of the list. All right, the next example on here says, start with a copy of your program from exercise 8.9, write a function called send messages that prints each text message and moves each message to a new list called set messages as it's being printed. After calling the function, print both of your lists to make sure that the messages were moved correctly. Okay, very good. So let me go ahead and let's just look at the code briefly here. Oh, it's a lot of code, right? A lot of code. So let's, so the body of the program starts really here on line 17, right? Because here are the two function definitions, right? I can collapse them if you want. See how I collapse them? So you can see that the body of the program is, the first thing I do is I create a list, and then I pass it to that list to show messages, right? And so inside of show messages, what it does is it gets each one of those and it prints it. Good. So then we come over here to line 20 and we create an empty list. And then we go ahead and call send messages, and we pass not only the messages list, but the sent messages list. So if we look at here, it passes in the list, and it also passes in that empty list. And what we're going to do here is we're going to iterate through messages, and we're going to pop them out one at a time, put it in a temporary variable, print the temporary variable, and then append that temporary variable to the sent messages. So as they're being popped out, then you're going to end up with nothing inside of messages. Okay, so then we go ahead and come over here to the final list. And what are we going to expect to see? We're going to expect to see messages is going to be completely empty, and sent messages is going to have something in it. So let's go ahead and run that. And let's look at the output. And yes, indeed. So here's the first printing, and here's what was sent. And here are the two lists printed. Okay, very good. So that brings us now to the next one here, 8.11, archive messages. Start with your work from exercise 10. Call the function set messages with a copy of the list of messages. After calling the function, print both of your lists to show that the original list has retained its message. Okay, so it's pretty much the same as before. Where does the magic happen here? Okay, where is, have I changed? Yeah, I haven't moved over to, I haven't clicked on 811 yet. Okay, so I was looking for the colon, right? Here's the call on line 22. We call send messages, and we pass messages, a copy of messages, so that when we run it, everything is the same as before, but at the bottom, the final list shows the original list has not been modified. Okay. All right. So let's try and do something a little bit different. Let's go through this with the debugger just to walk through it on here. So I'm just going to put a breakpoint right here on line 18, and then I'm going to go to run, start debugging, and click on Python file, and it stops right there at the breakpoint. Now, remember, the line that's highlighted is the line that has not executed yet. I could just go ahead and click on step into, but I'm just going to press F11, which is the same thing. So I press F11. Now look at this. It's going to call show messages. So look at what it does. It pops all the way up there to show messages. And when I point to messages, look, it shows me the contents of the list that was sent to it. It's going to go ahead and loop through the list. See how it's looping through it? It's looping through it. And then it goes to show messages, and it passes messages, right? Then we go and to the next one here, sent messages. And sent messages. In this particular case, it receives messages and sent messages, and it goes through it. And then it's appending it as we're going along. See how it's appending? And of course, this is being done to a copy, right? And then finally, it goes down to line 24. And here we're seeing the output as it's going through. And we can see the local variables on the left-hand side, which is kind of neat. We see how we sent you can see what the variables contain. You can even see the local variables, right? All right, so let's continue going through this with F11. So it prints final list. See how it said that? Then we go again. It calls messages, and it shows that it has not, the original list has not been modified because we sent a copy. And then it prints the sent messages. Okay, so that's pretty much the end of this program. And hopefully you found that informative or entertaining. I think it's good to see a walk through loops this way. It's also good to see the flow of control. Basically, just to repeat that idea is, for example, when I call a method, the flow of control leaves that line. Remember how we were on line 22? And the flow of control goes to send messages. And if you point to things, you can actually see what's popping into them, and you see it happening, right? You see the code go through the loop, and you're actually seeing the output occurring as you're stepping into every line of code. Okay, my friends, that's the end of this particular section. We have a few more sections here, but this section was simply about passing a list. Thank you very much. See you in the next video. Goodbye.